Hello all, my project is Water Quality Check. My name is Shivali Chaudhary and I am going to present what is how water quality is important for our life. Water is contamination is very serious issue of the world. Many people suffer from various diseases and even lose their lives. So this project will check the water quality and let you know that can you use that water? Not even you, your pets, animals, anybody else. Because right now, if we are using contaminated water, it will give us disease or we can lose our life. The water is most consumed thing in our life, and we need to take any measures and for ourselves and for the world even. And one of the incident is in September 2016. A water treatment plant had to shut down because of the polluted water flowed into the plants. And so I just want to make sure that a system can check the water quality and they can take any preventive methods if they came to know that the water quality is bad. To resolve this problem, my technical approach is I have used two sensors. One is TDS, another one is the turbidity sensor, which I connected with our ESP32 and taking the values and saving it to the database. I have directly ordered it from the Amazon. For the TDS sensor, it was giving me the output as analog. I am converted it into the voltage from the manufacturer. I came to know that this is the equation for converting it into the voltage. I have set up the TDS sensor at pin 0. The voltage I was taking is 3.3. By default, the value was 12 bits, so the range is 0 to 4096. So, hence, this becomes my equation. To calculate the TDS value from the literature review, I came to know about this equation. Through this value, we can convert the voltage into the TDS value. I have made a simple Python program to insert this TDS value into the database. My database was in the SQL and I'm using my Raspberry Pi as my server. The database was created using MariaDB and all the results which the stored in the database through one simple PHP script. I was echoing the data so that I can see the data is successfully saved. Later, I converted it into a downloadable CSV file. So, if you go to the link, it will download this in the format of CSV that I can use to make the chart. This was my setup. The submerged part is calculating the TDS value. TDS is total dissolved salts, and this is the TDS sensor. And this is connected to my laptop, so that I can take the values and save it. The turbidity is total solid particles inside the water. As you can see, like if you take soil water, you can see that it's like brown color or red color, and you cannot see anything. So it means it has the higher turbidity. But sometimes what happens to our naked eyes, we cannot see the fine particles inside the water, which is not good for us to consume. The same thing, turbidity sensor also I placed for at pin 0. This was the equation to convert into the voltage. For the turbidity, I was using 5 volts, so I multiplied it with 5. Um, uh, the uh, the turbidity is calculated in the NTU unit. So this is the relationship between the NTU and the voltage. This equation is not linear. That's why I couldn't convert it to NTU value, because I was getting a clear water voltage is around 2 to 2.5. But to apply to this equation, the clear water should come as 4.2, so it would give the turbidity 0. And in fact, if it is giving the high turbidity level less than 2.5 voltage, then it would give you your results start decreasing. So in that case also you cannot use the same linear equation. This was the same equation which I used. As I explained you, it was the non-linear equation, so I couldn't use it. There I found some other equations also, but I have not used it because I thought it's not from the reliable source, so maybe the turbidity would not be the exact. But I am calculating the turbidity voltage, and which would be the good for the analytical purpose, so that you can define threshold temperature that above that you cannot consume it. Um, this is the some screenshot of my echoing the values of the sensors. This is the three sample I took. One is milk water, one is clear water, and one is the soil water. And through this, I connected my sensor, and then I in this diagram I was inserting into the DBMS. For my project's success, before we go, I'll show you some demo videos. In fact, I made one separate YouTube video also for the demonstration purpose. But here I'll also try to show you one or more clip. This is my TDS, and this was TDS sensor setup. This was my turbidity sensor setup, and in the this is a little bit wrong. As you can see, I'm checking for the drinking water, and I am getting the values around 9.5 on my console. And here in the turbidity, I'm getting the voltage around 1.7 for this milk water. And this is some other clips. Uh, I made one web page to show my test results. So this is TDS. TDS is total dissolved salt. From the WHO, we have the reference, like if it is less than 300 ppm, then we can consume this water, like it's the excellent quality of water. Then there's good, fair, poor, and unacceptable quality of water. Right now in Hayward and in Sunnyvale, I tested the tap water, and it is coming around 965 ppm, which comes in the range of poor. It means it is hard water. It comes in the range of poor, but it is not unacceptable. The unacceptable range is about 1200. But it's always good if you can use some preventive methods, because it's the hard water, and for the drinking purpose definitely it would be very hard. Yeah, for testing purpose I added home salt into the water and trying to check the total dissolved sauce, and that comes around the 1900. Turbidity. For the turbidity, as I showed you in the diagram, I have the three samples. One is soil water, another one is milk water, and the third one is the tap water. So as you can see in the tap water is having the higher voltage. Higher voltage It means it has a less turbidity. And for the soil water, it is having very low voltage. It's around 1.6. From the diagram, we can give the threshold value. That would be 1.9. Like if you are above 1.9, you can consume that water, but if you are below 1.9, it's very unconsumable. Some of the milk reading comes above, so it depends. I tested for the one drop milk, and then two drops of milk, and drops of milk to test my turbidity value. You can always contact me through my email address. And uh, in my project, as we discussed, this is the project success. In my project report, I have also given the link for the my drive, and in drive I have added the data values, the charts, the in with the PHP file through which I make saving it into the CSV file, and charts and the Python scripts which I used. Um, Project success, I showed you the unexpected challenge was converting the turbidity voltage to NTU because it was non-linear equation. First I thought I could use it. Now then after from literature review I came to know no, it's non-linear. So it is giving me inconsistent result. Because of that, then I then after so much review I realized that I can use the turbidity voltage also has a graphical representation, and then I can give the threshold values, and through the threshold value I can provide it is consumable or non-consumable. It is not necessary to convert it into the NTU. I have got to know about this equation also, but it was just from one forum and not from any paper. So that's why I have not used it. And yeah, for the calculation purpose, temperature is also one of the important factor. So for now, I was not having the temperature sensor that is the waterproof. So uh, uh, that's why, because like with the higher temperature the turbidity would be less, and with the lower temperature turbidity would be high. And for that purpose I took a constant temperature 25 degrees Celsius water for every sample, so that temperature is would be constant. Lessons learned, I learned like how to handle the software, how to handle the things. IoT itself, it's good. So like when I was suffering with the turbidity and this NTU factor, I came to know that I can tune the voltage for the clear water to 4.2 volts, and then I can use. But as I was using the cheap turbidity sensor, so I cannot tune it well because its screw is not good. And when I tried, it just broke some about. So I was not able to tune it. And yeah, so I learned this small things also, and never to go give up. Always, if like you keep on trying and keep on reading and studying, you will come to some solution. Future work, I just want to make one uh application, or maybe it's Android or the website or something, like which I use the Google Maps. And through Google Maps, if you click on any place, you can get the water information about that place. For example, if you click Hayward, you can get the information of. So in that water information, I would like to include some more sensor also. For example, temperature sensor, pH sensor, and so that anybody user can get like exact what like how is the water there. And I also want to explore the water purifying methods, because right now I'm just checking and I'm just suggesting like you can consume that water or not, but it should be like some systems which through which I can purify the water and make it a good water for the consumption purpose. Here are the some link. One link is of my project setup, and the project was successfully running. And this is the web page which I showed you. And this is my project links and all other links. I hope you like it, and maybe it's useful for you to check the water if you travel somewhere, or if you uh, want to live somewhere to consume some water, you should know about the quality of water. So I hope you like it. Thank you.